Hi, this is Dr. Kumaran. Today we will discuss about 8085 microprocessor pin diagram. So before moving into the topic, we will discuss about what is microprocessor, because we need to define. Someone is asking what is microprocessor. Even though we have knowledge on microprocessor, we need to have some clarity how to define a microprocessor. That's what we'll do in this slide. The first thing is, whenever it is asked about a microprocessor, we need to have the physical appearance of the device. So physically it is an electronic component. You know that the integrated circuit means that connecting all the circuits in a single IC, in a single like this. So in this diagram you can see that it is a physical integrated circuit. Internally we have connected ALU, registers, everything. So all are electronic components connected inside as a single IC. The external signal transmission through the pins. These are all these physical signals are called pins of the microprocessor. So that's the first point. Second thing is, we can define this as a clock driven. Clock driven in the sense, you know that clock means train of pulses. Logic zeros and ones continuously it is varying. Any programmable device, it may be a microprocessor or controller, it will work based on its clock frequency connected with it. For example, when you buy a cell phone, it will be mentioned that the processor clock is 1 GHz, 2 GHz, 4 GHz like. So the gigahertz plays important role on deciding the performance of the device, because the frequency and time is inversely proportional. If the frequency is high, then the time period is very less. A microprocessor will take a number of clocks to complete one instruction execution. If your clock time period is very less, then it will complete instruction execution very quickly. Such way the overall performance of the system will improve. So that's the clock driven device. The next is, it's a programmable device. Programmable in the sense, few of the ICs like logic gates, flip-flops, those functions of the IC is predefined. We cannot change that. But the microprocessor function is not yet programmed in it. So when you buy a new IC, it doesn't have any program. So as a programmer, we need to write our own program to design our particular system. So that is called programmable here. The other important point is the sequential. We know that nowadays systems are designed to work on 24/7. For example, the surveillance camera, it is working 24/7, which means that when you write a program thousands of lines, it is connected with the microprocessor. The program is in memory, both are connected. Whenever powered on, the microprocessor will start fetching the instruction from the first memory location. Then automatically it keeps on moving second memory location, third memory location. Likewise, even 1000 or 10,000, whatever memory location we have, whatever number of lines we have written in the program, it will be executed one by one automatically. No need of any external intervention. This logic is called as sequential. So this leads that 24/7. What normally we'll do, if suppose 1000 line program, the 1100 line we will write jump to the first line. So automatically 1 to 1000, 1 to 1000, it will repeat how long the system is powered on. So that property is called sequential here. Then we can, the application wise, it is a multi-purpose device, which means that we can design many applications, from household appliances, the office appliances, networking, a number of applications we can say for microprocessor. So even in our calculators, microprocessor is used. So that's why we are calling as a multi-processor, multi-purpose. Then we can define it's a digital device. You know that digital and analog. Digital means it has only two distinctive levels, zeros and ones. But analog means we have a number of voltage levels. For example, the voice signal what we are talking, that is analog signal. So it is very difficult to process. That's why nowadays everything is digital. We'll convert all the analog into digital. Then the digital is easy to process because it have only two distinctive levels. So this is about definition. We can say that it is a physically integrated circuit. It's a clock driven. Based on the clock frequency, the speed of the device varies. It is a programmable device. We can change the function based on our required program. It is a sequential, automatically it will fetch all the instruction and execute without any external interference. It's a digital device, accepts only binary numbers. It will not process any analog signal. So we need to convert analog to digital, then only we can give it to digital. Then it is a multi-purpose. Based on the requirement, we can design the system for the specified application. This is not only for 85 microprocessor, any microprocessor or microcontroller, any programmable device, we can define such a way. Then we will move on to the pins and signals of 8085 microprocessor. 8085 microprocessor is designed and released by Intel Corporation. It is an 8-bit microcontroller. 8-bit means 8 binary digits it will take up for arithmetic and logic operations. On 2 8-bit numbers it will process, and the result also it may give based on the input numbers. So it's an IC, it is a 40-pin IC as you are seeing in the figure. Each side 20 pins are arranged. It is called a dual inline package, which is called a DIP package. In the 40 pins, the signals are arranged in a different category. That's what we are seeing in this diagram. It is easy to understand what are the signals available in this. The first category is power supply and frequency things. Power supply means any electronic component we need to enable, then we need a power supply. So here this is transistor logic based device, TTL logic. So we need a plus 5 volt between ground and VCC 20 and 40, then the device will be working. As the definition, it is a clock driven device. We need to connect external frequency at this point. So that is between x1 and x2 we need to give a clock. Internally the 85 has a clock divider circuit divided by 2. For example, if you are connecting a 6 MHz crystal here, it will divide this by 2. 3 MHz will be the operating frequency. This is a very old IC, about 1980s the IC is designed and released, so the frequency of operation is very less. But nowadays it is 5.9 processor is operating on 5 GHz. This is in megahertz. So the high speed is achieved whenever you increase this frequency, but there is a limitation for every design that you can refer the manual. Then we have signals called reset in, reset out, and clock out. So the clock out also a signal. Clock out means the operating frequency will be given as output also, because when you design a microprocessor based system, it is not only the microprocessor IC, we need lot of peripherals to define a system. That's what we are seeing in a computer motherboard. You can find a number of ICs there. So for the peripherals also we need a clock. For in that case this clock will be given as an input for the other peripheral devices which are connected in the system. Then the reset in is a signal. Whenever you reset in to the microprocessor, reset means whenever the microprocessor is stuck up, any application is hang, we are not able to proceed, that time we will give a reset in, which means that it will start from the fresh. It will erase all the internal registers. It will start fetching the first memory location. Obviously the first memory location we will have operating system code. So from then onwards it will start. So whenever we reset the 85, it will reset the entire system through that reset out. Then we have address and data, both important signals in microprocessor. Address bus means we have 8-bit address bus because 8-bit microprocessor is. So AD0 to AD7, in that A0 to A7, D0 to D7, both are multiplexed in this. Multiplexed means the same pin will act as an address for some time, some other time the same pin will act as a data. So that's the thing. Here the data bus is bidirectional because microprocessor has to read and write the memory or IO devices. That's why it is bidirectional. 8 lines D0 to D7. Address lines, we have 16 address lines A0 to A15. Address lines are always unidirectional because microprocessor only decides which address. It will place the address value on the bus. It will enable that any memory, identify memory or IO device. Then through data bus, it will read and write data through that. So totally 16 address lines. The memory capacity of any IC is 2 power n. N is the number of address line. In this case, we have 16 address lines, 2 power 16, 64 kilobytes of memory it will connect. So 64 kilobyte of memory we can connect, because 2 power 16 equal to that 64 KB memory. So just imagine, nowadays we are using memory in terms of gigabits, terabytes, but this processor will support 64 KB. That's enough to design an application, simple application systems. That's why it has started with the very low memory. Then we have signals like control and status. Here the control and the status signals. The control signal means read, write, IO bar, M bar. So these three are control signals. Control in the sense, suppose you want to read an input device, the read signal is enabled here. Some of the signals are active low here, which means a bar, which indicates that active low signal. Normally the signal is high. Whenever signal is enabled, that time only it will become 0. That is active low signal. Read, write, IO/M means the microprocessor will use the same address and data bus for both IO device as well as memory to differentiate whether it is using currently accessing IO or memory based on IO bar, M bar. So IO, if it is the pin is 1 means IO device access, 0 means memory device access. Then we have S0, S1. These two are status signals. Currently what the microprocessor is doing, microprocessor will do repeatedly opcode fetch, read, write, then halt. So only 4 states it will be. So those status we can identify by enabling, by reading these two signals, S0, S1, 2 power 2, 4 combination. By using this we can enable, you can find out what processor is doing currently. Then there is a signal called ALE, address latch enabled. This is the signal which is used to demultiplex AD0 to AD7 to D0 to D7, A0 to A7. Even though it is in the same pin, physically we need two signals, address and data at the same time when you access memory or IO device in real time. So with the help of ALE we will demultiplex. So that is given in this. Look at this, A0 to AD0 to AD7 given into a latch. The latch is a single bit memory. It will remember whatever the input you have given. So that's the latch here, 8-bit latch. So which is given here. The latch is AD0 to AD7 8-bit latch. There is an enable signal through that ALE. Whenever this signal is enabled, the input is connected to the output. So that's the meaning of latch. Suppose we remove this enable, then it is disconnect this. So it will maintain the previous output continuously until you are enabling that enabled device. So that's the meaning of this latch. So if ALE is 1, the microprocessor will place the address value on this common bus, enable the ALE, address is latched, which means that address is constantly maintained. Then it will remove that ALE signal. Remove means it will maintain the previous address value as output here. Then the remaining signals here, this bus will act as a data by this way. So physically we have address and data, both are available at the same time. Then it is connected with the memory and IO. You can access this. The higher order address only address only, so directly we can have. So 16 address and 8 data buses are available after this latch. 74373, it is a 8-bit latch. Then we have signals like a serial in and serial out. Serial in data, serial out data means it's a communication pin. We need to transfer data from microprocessor to the external world through these two pins. So as you know that serial and parallel communications are possible. Parallel means as a 8-bit data we need to have 8 parallel lines. So which is not possible always. Within a board means it's possible, but if you want to connect external device like our USB, some of the cables and all, we need very minimum number of wires. That time we will use this serial. So serial in data means whatever data is coming here, it is 1000, like the binary numbers are coming one by one, that is converted serial to parallel, then it is transmitted given to the CPU. While serial out data also, from parallel 8-bit data, it is converting bit by bit and transmitting through this single pin. That is called the serial out data. These two are serial port pins. Then we have interrupt signals. Interrupt means whenever the microprocessor executes one task, if any other task is coming, then the current task is stopped. It goes to that interrupting task. It will complete that. Again, it will come back. The best example is our cell phone. We are using multimedia. Whenever call comes, it will indicate you. If you are attending the call, it will continue the call. After disconnecting, it goes back to the previous multimedia application whenever you disconnect the call. So that's the example of interrupt. 85 will support for 5 interrupts: trap, RST 7.5, 6.5, 5.5, INTR. RST means restart interrupts. Trap is a non-maskable here. Non-maskable in the sense we cannot disable the interrupt. Some interrupts we can disable. Even in our cell phone we have gaming mode. When you enable that gaming mode, it will disable even the network. So that is called disabling the interrupt. INTR is called the interrupt request. The external device make a request through the hardware pins. The processor will stop the current task, goes to that particular device, execute that program, then it will come back to its main task. The INTA means interrupt acknowledge. So whenever device making a request, it is giving acknowledgement to the device before taking the control over the device. Then we have two signals ready. Ready means it is when we use microprocessor in a system, the peripherals are slower compared to the microprocessor. So the speed of microprocessor is transacting data, the external device may not accept. So it will be connected from the external device ready pin. So whenever the device is ready, it will intimate the CPU microprocessor. Then the processor will start a new data. Then wait for next ready. So whenever ready comes, the microprocessor start transacting data with that particular signal. Then we have hold acknowledge. Two pins are there. That is called DMA, direct memory access. This system is given here. It's a microprocessor, memory, IO device, DMA. Generally, the data transaction is my IO device will inform the CPU. CPU will take the data and give it back. So that's the general data transfer. It is a time consuming and overhead for the CPU. To overcome that, the new logic is introduced here, DMA, direct memory access. That controller is connected. Whenever IO device wants to access memory, it will intimate the DMA controller. DMA controller will ask the processor permission with the help of hold. The processor will give the permission through HLDA. Then DMA controller enable the connection between IO device and memory directly. The data transaction happening between IO and memory directly at a high speed. Whenever it completes, it will remove that request here. Then the DMA will remove the hold signal. Processor will remove the acknowledgement. Then the normal function is taken back by the microprocessor. So that's the function of DMA signals, hold and HLDA. So it's likewise, all the signals are discussed here. A 8-bit microprocessor. So that's all about pin diagram. If you have any doubt on clarification, you can ask in the comments. I will answer. Thank you.